Welcome to Cloud ngfw Deep Dive. Welcome to the channel. Please consider subscribing. I produce videos covering AWS, Azure, and GCP on a daily basis. Please also hit the bell button to get notified. Today we'll transform your understanding of network security. Think of this as upgrading from a basic security guard who only checks IDs to a sophisticated airport security system that can see inside luggage, check against watch lists, and understand traveler intent. By the end of this presentation, you'll not only understand the architectural differences between traditional and next-generation firewalls, but you'll also have hands-on experience creating intelligent security policies using real G-Cloud commands, YAML configurations, and JSON policy definitions. We'll cover everything from the theoretical foundations to practical implementation, including detailed explanations of every command parameter, configuration file structure, and best practices for enterprise deployment. The fundamental problem. Let me start with a story that many of you will recognize. For years, organizations have relied on traditional firewall rules. These are simple allow and deny lists based on IPs and port numbers. I like to compare this to having a security guard at your office building who has a basic checklist. This guard checks your ID badge. That's your source IP address. They verify which floor you're going to. That's your destination IP, and they make sure you're using the right elevator bank. That's the port number. This system works, but it's fundamentally limited. The guard has no idea what you're carrying in your briefcase, why you're visiting that particular floor, or whether you're actually supposed to be in the building at all. In networking terms, this is Layer 3 and Layer 4 security. It only sees packet headers, not content or context. In today's threat landscape, attackers use legitimate ports, encrypted traffic, and sophisticated evasion techniques. This approach leaves massive security gaps. We need intelligence, context, and the ability to understand what applications are actually doing, not just where packets are going. Understanding the new architecture. Cloud ngfw introduces a completely new paradigm for managing network security through a hierarchical policy structure. Instead of managing individual rules scattered across multiple VPCs, we now work with centralized policies that can be applied consistently across our entire infrastructure. The key innovation here is the concept of firewall policies as containers for rules, and firewall endpoints as the enforcement points. When you create a policy association, Google automatically deploys these endpoints to transparently inspect all traffic flowing through your VPC. This architecture supports both global policies, created at the organization or folder level for company-wide security standards, and regional policies for application-specific requirements. The hierarchy allows for inheritance and override patterns, giving you both consistency and flexibility. What is particularly powerful is that a single policy can be associated with multiple VPCs, enabling you to define security once and apply it everywhere. This eliminates the configuration drift and management overhead that plagued traditional firewall deployments. Layer 7 Intelligence Explained. Now let's dive deep into what makes this truly next generation. The fundamental difference lies in the inspection capabilities. Traditional firewalls operate at the network and transport layers. They can see IP addresses, port numbers, and basic protocol information. Cloud ngfw operates at the application layer, Layer 7 of the OSI model. This means it can perform deep packet inspection to understand the actual content and context of network traffic. It's like the difference between a postal worker who only looks at addresses versus one who can open packages and inspect contents. This capability enables features that were impossible with traditional firewalls. FQDN filtering allows you to create rules based on domain names rather than constantly changing IP addresses. Threat intelligence integration automatically blocks traffic from known malicious sources without any manual intervention. The system can also identify applications regardless of port numbers, detect encrypted threats, and make decisions based on user ID through integration with Google Cloud IAM service accounts. This level of context awareness transforms firewall rules from simple packet filters into intelligent security policies. Comprehensive feature comparison. Let me walk you through a detailed comparison that really highlights the capability gap between traditional and next-generation approaches. In traditional VPC's firewall rules, you're limited to basic 5-tuple matching: source IP, destination IP, source port, destination port, and protocol. With Cloud ngfw, you get all of that plus so much more. You can create rules based on fully qualified domain names, which automatically resolve to current IP addresses and handle CDN changes transparently. Geographic location filtering lets you block entire countries or regions with a single rule. The threat intelligence integration is particularly powerful. Google maintains continuously updated lists of malicious IPs, botnets, and known attack sources. Your firewall automatically benefits from this intelligence without any configuration changes on your part. From a management perspective, the centralized policy model eliminates the scaling challenges of traditional firewalls. Instead of managing hundreds of individual rule sets across different VPCs, you define policies once and apply them consistently across your entire infrastructure. Cloud native versus third-party NVA. One of the most common questions I get is about the relationship between Cloud ngfw and third-party solutions like Palo Alto Networks. This is a great question because it highlights two fundamentally different architectural philosophies. Cloud ngfw is a fully managed, cloud-native service that is deeply integrated into Google's network fabric. There are no virtual machines to deploy, no licenses to manage, no patches to apply. Google handles all the scaling, availability, and maintenance automatically. Third-party network virtual appliances like Palo Alto VM Series are essentially traditional firewall software running on Google Compute Engine virtual machines. You are responsible for sizing, deploying, configuring, patching, and scaling these appliances yourself. The integration story is also quite different. Cloud ngfw natively understands Google Cloud constructs like service accounts, VPC networks, and IAM policies. Third-party solutions typically integrate through standard networking mechanisms and may require additional configuration for cloud-specific features. Both approaches have their place. Cloud ngfw excels when you want powerful security with minimal operational overhead, while third-party solutions might be preferred when you have specific feature requirements or existing vendor relationships. Creating your first policy, a deep dive. Now let's get our hands dirty with the actual implementation. We'll start by creating a regional firewall policy, which serves as the container for all our intelligent security rules. I want to walk through every parameter in detail, because understanding these options is crucial for proper implementation. The project parameter specifies where this policy resource will be created. Remember that regional policies are project scope resources, unlike global policies which exist at the organization or folder level. The description parameter might seem optional, but I cannot stress enough how important good documentation is for security policies. 6 months from now, when you're troubleshooting a connectivity issue or conducting a security review, these descriptions will save you hours of investigation time. The display name becomes the human-readable identifier in the Google Cloud Console. I recommend using a naming convention that includes the environment, application, and purpose, something like Prod Web App Security Policy or Dev Database Access Policy. We'll also look at the JSON representation of this policy, which is useful for infrastructure as code deployments using tools like Terraform or when you need to export and import policies between environments. Threat intelligence rules, the first line of defense. Our first rule demonstrates one of the most powerful features of Cloud ngfw, automatic threat intelligence integration. This rule will block known malicious IP addresses before they can even attempt to reach your applications. The priority number 100 is critically important. Firewall rules are evaluated in ascending order of priority, so lower numbers are checked first. I always recommend starting threat intelligence rules at priority 100 to ensure they're evaluated before any allow rules. The source threat intelligence parameter is where the magic happens. Google maintains several curated threat intelligence feeds including known malicious IPs, botnet command and control servers, and cryptocurrency mining pools. These lists are updated continuously without any action required on your part. What's particularly powerful about this approach is that it's proactive rather than reactive. Traditional firewalls require you to manually identify and block threats after you become aware of them. With threat intelligence integration, you're protected against known threats before they ever reach your network. I'll show you both the G-Cloud command syntax and the equivalent YAML configuration that you might use in a CI/CD pipeline or infrastructure as code deployment. FQDN filtering beyond IPs. Now we will implement one of the most requested features in modern firewalls, the ability to create rules based on domain names rather than IPs. This solves a massive operational challenge that every network administrator has faced. Traditional firewalls require you to manually track and update IPs for external services. But think about services like GitHub or Google APIs. They use content delivery networks with hundreds of IPs that change frequently. Maintaining static IP lists is both error-prone and operationally expensive. FQDN filtering allows you to specify rules like allow access to star.google.com, and the firewall automatically resolves current IPs in real time. The wildcard support means you can cover entire service domains with a single rule. The target service accounts parameter demonstrates another next-generation capability, identity-based access control. Instead of broad network-based rules, you can restrict access to specific service accounts. This implements the principle of least privilege at the network level. I will walk through the detailed parameter breakdown and show you the JSON policy representation that includes all the metadata and configuration options for this rule type. Policy association, activating your security. Creating a policy is only half the battle. It doesn't actually protect anything until you associate it with a VPC network. This association command is what creates the firewall endpoint and begins enforcing your intelligent rules. The association creates a binding between your policy and your network infrastructure. Behind the scenes, Google deploys transparent inspection points that examine all traffic flows without impacting network performance or requiring route changes. One policy can be associated with multiple VPCs, which is incredibly powerful for maintaining consistent security across different environments. For example, you might have the same security policy applied to development, staging, and production VPCs to ensure consistent protection. The name parameter for the association becomes important when you need to manage or update these relationships. I recommend using descriptive names that clearly indicate which policy is associated with which network. I'll show you the complete association process, including verification commands to confirm your policy is active and properly enforcing rules. Traffic flow and inspection process. Understanding exactly how traffic flows through Cloud ngfw is crucial for troubleshooting and performance optimization. Let me walk you through the complete inspection process that happens transparently for every packet. When a virtual machine initiates a connection, the packet first reaches the firewall endpoint, a transparent inspection point that Google deploys in your VPC. This endpoint captures the packet and forwards it to the Cloud ngfw inspection engine. The inspection engine evaluates rules in strict priority order. In our example, it first checks if the source IP appears on any threat intelligence lists. If there's no match, it continues to the next rule. For FQDN rules, the engine performs real-time DNS resolution to determine if the destination matches the specified domain pattern. This happens efficiently using Google's global DNS infrastructure. Once a rule matches, the specified action is taken, either allow or deny. If the packet is allowed, it's forwarded to its destination with minimal additional latency. The entire process typically adds less than a millisecond to connection establishment. This sequence diagram illustrates the complete flow and helps you understand where to look when troubleshooting connectivity issues or performance concerns. Advanced configuration and JSON examples. As we move toward more advanced deployments, understanding the complete JSON schema becomes essential. This is particularly important when you are implementing infrastructure as code or need to programmatically manage large numbers of policies. The JSON representation includes all the metadata, configuration options, and advanced parameters that might not be immediately obvious from the G-Cloud command syntax. You will see fields for logging configuration, rule descriptions, and advanced matching criteria. I want to show you practical examples of complex rules that combine multiple matching criteria. For example, a rule that allows traffic from specific service accounts to particular FQDNs during certain time windows. These advanced patterns become crucial in enterprise environments. We will also cover the YAML format that is commonly used in GitOps workflows and CI/CD pipelines. Understanding both JSON and YAML representations ensures you can work effectively regardless of your deployment methodology. Finally, I will share some practical tips about rule ordering, priority management, and common pitfalls to avoid when scaling these configurations to production environment. Enterprise best practices and deployment patterns. As we wrap up our technical deep dive, let me share some hard-learned lessons about deploying Cloud ngfw in enterprise environments. These best practices come from real-world implementations across various industries and organization sizes. Role prioritization is absolutely critical. I recommend establishing standard priority ranges. For example, 0 to 99 for deny all and emergency rules, 100 to 199 for threat intelligence, 200 to 299 for application-specific allows, and so on. Document these conventions clearly and enforce them through policy. Logging and monitoring deserve special attention. Cloud ngfw integrates with cloud logging and cloud monitoring, but you need to explicitly configure what gets logged. I'll show you the logging configuration options and recommend which events are most valuable for security operations. Testing is crucial but often overlooked. Always test new rules in a development environment first, and consider using the preview mode for complex policy changes. The impact of a misconfigured firewall rule can be immediate and severe. For organizations with compliance requirements, document everything. The audit trail capabilities of Cloud ngfw are excellent, but you need to configure retention and export policies appropriately for your regulatory environment. Finally, consider the operational model. Who manages these policies? How do you handle emergency changes? What's your incident response process when firewall rules need immediate modification? These process considerations are just as important as the technical implementation. Troubleshooting and monitoring. Before we conclude, let's discuss the operational aspects of running Cloud ngfw in production. Monitoring and troubleshooting are essential skills that will save you countless hours of investigation time. Cloud ngfw provides extensive logging capabilities through cloud logging. You can log allowed connections, denied connections, or both. I strongly recommend logging denied connections at a minimum. This data is invaluable for troubleshooting connectivity issues and identifying potential security threats. The logs include detailed information about which rule was matched, source and destination details, and timing information. Learning to read these logs effectively is crucial for operational success. Google Cloud Console provides excellent visualization tools for firewall logs, but you should also consider integrating with your existing SIEM or monitoring solutions. The structured log format makes this integration straightforward. Performance monitoring is equally important. While Cloud ngfw is designed for minimal latency impact, you should establish baseline measurements and monitor for any degradation. Google provides detailed metrics about rule evaluation times and throughput. I'll show you the specific G-Cloud commands for accessing logs, the Cloud Console interfaces for visualization, and examples of useful log queries that help with common troubleshooting scenarios. Conclusion and next steps. Congratulations! You've now completed a comprehensive journey through Google Cloud's next-generation firewall capabilities. You understand the architectural foundations, the practical implementation details, and the operational considerations for enterprise deployment. Let's recap what we've covered. The fundamental differences between traditional and next-generation firewalls, the policy-based architecture that enables centralized management, and the Layer 7 inspection capabilities that provide unprecedented visibility and control. You've seen detailed command explanations with every parameter documented, JSON and YAML configuration examples, and real-world best practices from enterprise deployments. Most importantly, you understand how to implement intelligent security policies that adapt automatically to changing threat landscapes. Your next steps should include exploring the intrusion prevention service for even more advanced threat detection, implementing comprehensive logging and monitoring, and developing operational procedures for your security team. Consider starting with a proof of concept in a development environment, gradually expanding to production workloads as your team gains confidence with the platform. Remember that security is a journey, not a destination. Cloud ngfw provides the foundation for intelligent, adaptive network protection that grows with your organization's needs. Please hit the subscribe button if you haven't done so already. Thank you for your attention, and I'm excited to see how you implement these capabilities in your own environments.